everybody. This is Batman. Hello. Oh, no, you don't like that. So he's joining me on this chilly evening. And looks like he'll be keeping us company. So I hope your day is treating you well. Let me switch over to our screen where we are resuming with revision on Unit 4, Lists and Strings. There we go. So we have managed to make some progress after finishing those exercises, which were a little bit challenging, but good practice nonetheless. So we've done indexing, slicing, and now we are going to be looking at list methods. So it looks like we have some more examples to do. So I'm not sure if you have done so, but it's probably a good idea to take some notes of all the theory that's covered in this unit. It's a lot to just remember, off the top of your head, especially as beginners. So that helps a little bit instead of rocking back and forth between our notes. So it says that we should practice these examples using Replit to become more familiar with some methods commonly applied to lists. As you go through these examples, you should begin to see how powerful Python can be as a programming language. Python has a great built-in list type named list. List literals are written within square brackets. Lists work similarly to strings. Use the len function and square brackets to access data with the first element at index 0. So you see here we can print whatever element is in index 0. Assignment with an equal on list does not make a copy. Instead, assignment makes the two variables point to the one list in the memory. So B does not copy the list colors. The empty list is just an empty pair of brackets. The plus works to append two lists. So this list over here, 1 and 2, plus this list over here, 3 and 4, will yield a list 1, 2, 3, 4. This is just like plus with strings. For and in. Python's for and in constructs are extremely useful, and the first use of them we'll see is with lists. The for construct, for var in list, is an easy way to look at each element in a list. Do not add or remove from the list during iteration. So remember, we use our for list to iterate over we use our for loop, to iterate over a loop. So in this example, we have our variable called squares, which is a list. We initialize sum to 0, and basically what we are doing is for num in squares, sum plus equals num. So we're going to keep adding each element to sum. If you know what sort of thing is in the list, use a variable name in the loop that captures that information, such as num or name or URL. Since Python code does not have other syntax to remind you of types, your variable names are a key way for you to keep straight what is going on. The in construct on its own is an easy way to test if an element appears in a list or other collection. So value in collection tests if the values in the collection returning to true or false. So that's important to remember. So we've got an if statement. Remember, if works with Boolean values. So if curly is in our variable over here, list, then print yay. It will print yay if it's true. The for in constructs are very commonly used in Python code and work on data types other than list. So you should just memorize their syntax. You may have habits from other languages where you start manually iterating over a collection, where in Python you should just choose for in. You can also use for in to work on a string. The string acts like a list of its chars. I think they mean character. So for ch in S, print ch, and basically it will print all the chars in a string, or chars. Not sure. The range function yields the numbers 0, 1, so on, n negative 1, or n to 1. And range AB returns A plus 1, so on. 2, but not including the last number. The combination of the for loop and the range function allow you to build a traditional numeric for loop. So for I in range 100, it will print I. Remember, it will only print from the index 0 through to 99. There is a variant X range which avoids the cost of building the whole list for performance sensitive cases. In Python 3000 or 3, I don't know, range will have the good performance behavior and you can forget about X range. Yeah, so we're working on Python 3. While loop. Python also has the standard while loop, and the break and continue statements work as in C++ and Java, altering the course of the innermost loop. The above for in loops solves the common case of iterating over every element in a list, but the while loop gives you total control over the index numbers. Here's a while loop which accesses every third element in a list. So don't forget we need to initialize our I to 0, and then we say while I is less than len A, prints a I. Excuse me. I equals I plus 3. This I would think is the list. Okay, list methods. Here are some other common list methods. List.append adds a single element to the end of the list. Common error does not return a new list, it just modifies the original. List.insert, and then in your brackets you can put the index and your new element. Inserts the new element at the given index, shifting elements to the right. List.extend adds the elements in list 2 to the end of the list. But remember that using plus or plus equals on a list is similar to using extend. List.index, and in brackets your element, searches for the given element from the start of the list and returns its index. It throws a value error if the element does not appear. Use int to check without value error. So I hope you guys are taking notes. List.remove element searches for the first instance of the given element and removes it. List.sort. It sorts the list in place, but it does not return it. Okay. The sorted function shown later is preferred. Oh, interesting. Sorted. So we have sort and sorted. List.reverse reverses the list in place. Remember again, it does not return it. List.pop index removes and returns the element at the given index. So that's useful if you remember, if you're removing, then you're quite simply removing the element. But if you use pop, it will remove it, but it will also return the element. So if you need that element, then you would use pop. Now remember, it will return the rightmost element if index is omitted. Notice that these are methods on a list object, while len is a function that takes the list as an argument. Note that the above methods do not return the modified list, they just modify the original list. So this applies to .append, .insert, .extend, .remove, and .pop. One common pattern is to start a list A, the empty list, then use append or extend to add elements to it. Slices work on lists just as with strings and can be used to change subparts of the list. So if we print here list starting at index 1, and remember -1 works from the right to the left. Remember 1 is inclusive, so 0, 1, meaning it will print B, but this over here is exclusive. Okay, so it's not going to print D, it will print C. The same for here, it will print 0 to 2, so it will start at A, but it will end at 1. Okay. And in this case, because we have values here, on the left-hand side of the equals, it will replace A and B with Z. I see we did that already. I'm sorry if I'm repeating. I was not feeling too well in the last video. So it could be that. My sincere apologies for that. Okay, list comprehension. Python offers many opportunities for creating efficient programming structures. When it comes to writing loops, list comprehension allows for very compact code. Using lists, it is possible to pack quite a bit of power using just one line. This is an optional topic that requires understanding how to write loops using lists. Practice the examples to expand your ability to write loops. We have practiced our 12 examples. Doesn't look like there's more. So the easiest way to sort is with the sorted, and then in brackets, lists function, which takes a list and returns a new list with those elements in sorted order. The original list is not changed. So I'm going to make a note here of sorted because that's quite useful and it's important to know the difference. So we have sorted and then our list, and that returns a new list, as opposed to sort, which just sorts, but it doesn't actually modify the list. It's most common to pass a list into the sorted function, but in fact it can take as input any sort of iterable collection. The older list.sort method is an alternative detailed below. The sorted function seems easier to use compared to sort, so I recommend using sorted. The sorted function can be customized through optional arguments. The sorted optional argument reverse equals true makes it sort backwards. Oh my goodness. We should probably make a note of that. Interesting syntax. So we have sorted and then our list. And then you can put a comma and say reverse equals true to sort a list backwards. For more complex custom sorting, sorted takes an optional key equals, specifying a key function that transforms each element for comparison. The key function takes in one value and returns one value, and the returned proxy value is used for the comparisons within the sort. This probably makes sense when we look at the example. For example, with a list of strings, specifying key equals len, the built-in len function, sorts the string by length from shortest to longest. The sort calls len for each string to get the list of proxy length values and then sorts with those proxy values. That's odd. So we know that key transforms each element. And you notice in this example where here we have one character, then two characters, three, then four. So it looks like that is a way of sorting strings within a list according to the length of the words. So I'm also going to make a note of that. Key equals len. So it will sort the string by length. That makes sense now. As another example, specifying str.lower as the key function is a way to force the sorting to treat uppercase and lowercase the same. Just want to see here, key equals len. They got my notes. Okay, so we can also say key equals str dot lower. So uppercase and lowercase are treated the same. You can also pass in your own myFn as the key function like this. Say we have a list of strings we want to sort by the last letter of the string. So this is our list, but we want to sort it according to this over here, the last character. So write a little function that takes a string and returns its last letter. This will be the key function. Oh, interesting. So we would say our function is myFN. I presume that's first name. Don't know. We know this. We should know it by now. S -1, so it's going to return it's going to return the last character. But now we do, of course, need to use the key so that it looks at it element by element and not as the whole string. So I think I need a new page because I've run out of space. But I'm just going to make a note of that. So it returns the last letter of a key string. I'm going to use the word key string. To use key equals custom sorting, remember that you provide a function that takes one value and returns the proxy value to guide the sorting. There is also an optional argument, CMP equals CMPFN, to sorted that specifies a traditional two-argument comparison function that takes two values from the list and returns negative or 0 or positive to indicate the ordering. The built-in comparison function for strings is CMPAB, right? So you want to call CMP in your custom comparator. The newer one-argument key equals sorting is generally preferable. That sounded like a mouthful. I am now looking back to our exercises. So it seems like this isn't all arranged entirely methodically. There was a particular exercise that basically required us to, if you imagined having a list of like 1,000 words or 100,000 words, and you want to check if a word is in the list. Well, iterating over 100,000 words is going to be slow, and it's probably not the most ideal. You can be smarter about it by dividing the book up right into, if you think of it, the list as a book, into half, and you quite simply check whether the word qualifies to fit within the first half, or if not, if it's not in the first half, right, or the second half, then the word's not there, but you've basically cut down your searching by half. So we had not covered the key element, like this example over here, which is probably how we would go about doing that. As an alternative to sorted, the sort method on a list sorts that list into ascending order. So we would say list.sort. The sort method changes the underlying list and returns none. So use it like this. This is incorrect because it's going to return none. We can't assign a variable when using .sort. The above is a very common misunderstanding with sort. It does not return the sorted list. The sort method must be called on a list. It's, I guess, kind of similar to initializing a value. because I've noticed sometimes the code won't work unless you like initialize it, or you initialize a certain value. So yeah, it's the same with lists. So if you're relying on it being in alphabetical order, you just use dot sorted. You just call on it, but you don't actually assign a variable to it or create a new list out of that unless you're using sorted. The sort method must be called on a list. It does not work on any enumerable collection, but the sorted function above works on anything. The sort method predates the sorted function, so you will likely see it in older code. The sort method does not need to create a new list, so it can be a little faster in the case that the elements to sort are already in a list. So remember we did tuples, especially when we were formatting strings. So here we're going to look a little bit more at some tuples. So a tuple is a fixed size grouping of elements such as an XY coordinate. Tuples are like lists, except they are immutable and do not change size. Tuples are not strictly immutable since one of the contained elements could be mutable. Tuples play a sort of struct role in Python, a convenient way to pass around a little logical fixed size bundle of values. A function that needs to return multiple values can just return a tuple of the values. For example, if I wanted to have a list of 3D coordinates, the natural Python representation would be a list of tuples where each tuple is size 3 holding one XYZ group. So if that's sounding a little confusing to you, I would recommend you go back to the video where we have covered tuples. And that was in our video where we did formatting of strings on learnpython.org. To create a tuple, just list the values within parentheses separated by commas. The empty tuple is just an empty pair of parentheses or parentheses. Accessing the elements in a tuple is just like a list, len, for, in, etc. all work the same. So tuple equals 1 to high. So if we print the length of the tuple, we are going to get 3. And index 2 would be high. Tuples cannot be changed. So you see here they're trying to change it. But this will work. To create a size 1 tuple, the lone element must be followed by a comma. It's a funny case in the syntax, but the comma is necessary to distinguish the tuple from the ordinary case of putting an expression in parentheses. In some cases, you can omit the parenthesis and Python will see from the commas that you intend a tuple. Assigning a tuple to an identically sized tuple of variable names assigns all the corresponding values. If the tuples are not the same size, it throws an error. This feature works for lists too. So you see here, we've got our tuple here and our tuple here. So if we print Z, it will print hike. That is very interesting. It seems like a way of, in like I guess one line of code, assigning multiple values to different variable names, where we can just separate the variable names by commas and likewise the values. Sorry. List comprehensions are a more advanced feature, which is nice for some cases, but is not needed for the exercises and is not something you need to learn at first. You can skip this section. A list comprehension is a compact way to write an expression that expands to a whole list. Suppose we have a list, numbers 1, 2, 3, 4. Here is the list comprehension to compute a list of their squares. This makes sense. So we have nums, and basically it seems like we have, I don't know if you would call this an expression, but it looks like you can create a list by saying, actually putting in an expression within the brackets, and this time into the power of n, for n in nums. So we don't need to get confused here. This is a for statement for n in nums. In other words, nums is our list over here, and we are just iterating over each element, which is basically n, and we're raising it to the power of itself. So I can see how that would have actually also helped us in our earlier exercises. The syntax is expression for variable in list. The for variable in list looks like a regular for loop, but without the colon. The expression to its left is evaluated once for each element to give the values for the new list. Here is an example with strings, where each string is changed to uppercase with exclamation marks appended. So we have our list here called strings, and we say for s in strings, so each s here, each element, we're going to say s dot upper, and we're going to basically concatenate it with these exclamation marks here. And now we can see it's all changed to uppercase. So I'm going to just write this down as an example. And we just basically create our new list. So this is actually, I was wondering, what's the point of methods, right? Like dot upper is a method if it just returns a 0 value. So now I can see how it can work by adding the expression within the string, and then in this case we've actually created a new string even though we are using dot upper in this example. SNSTS, and it's going to print hello. and so on. Just want to quickly see here. Make a note of these tuples as well, because that's quite actually interesting. So 42, 13 hike. If we print Z, it's going to give us hike. You can add an if test to the right of the for loop to narrow the result. The if test is evaluated for each element, including only the elements where the test is true. So in this case, we are creating a new list where for n in nums, if n is smaller than or equal to 2, in which case it's only going to give us 2 and 1. Or in this case, select fruits containing A, change to uppercase, So let's look at this example. S.upper for, so we're going to apply the upper function to S, which is basically each element. For S in fruits, this list over here, if A in S. So we change it to capital letters. And I'm just going to make a note of that as well. Oof. S dot upper for S in fruits if A in S. Okie guys, I really actually am pushing to finish with Unit 4. We're already on part 5 of just doing Unit 4. So just strings revisited, string methods. Yeah, it looks like it's just still quite a bit probably. I think if we don't finish it in this video, we will definitely by the next video. So I'm going to quickly run a short break, grab some much needed coffee, and I will see you in 10 minutes.
That's fine, bro. You're the person that we make fun of. We take you and we take your chart and we make fun of it. We put the two charts next to each other and we cuckold you and we say, look, we're banging the mad games.
Currency. Collectively, central banks are working to issue in a new system, and that means destroying the purchasing power of the currency and bringing down an entire class of people with it.
Characterize Bitcoin as a digital currency. You can call it digital gold. You can call it digital cash. You can think of it as digital money. You can think of it as digital property. You can think of it as digital capital. You can think of it as digital energy. You can think of it as a digital asset.
Government can just stop Bitcoin tomorrow. Liberty Reserve was shut down across 42 countries. Bitcoin can be like that, tomorrow banned. The way that they shut Liberty Reserve down was the Americans issued a financial services order. Anyone who took Liberty Reserve was banned from the banking system anywhere on earth. Basically, it means your whole company's wiped off the face of the earth. And they could do that. And they can do that to Bitcoin right now.
This is fine.
back. Okay, let's resume. So now we are doing some more revision on strings. So list concepts such as methods, indexing, and slicing are also important for dealing with string objects. While there are some similarities in the syntax of processing strings and lists, there is a major difference in how Python views strings versus lists. Lists are mutable, which means that once created, as we have already seen, the elements contained in a list can be changed and updated. Strings are immutable objects. This means that once they are created, they cannot be changed, such as by using assignment operation equal. Because of string immutability, this example would yield an error. So A equals ASDF. If we try and print, for example, in this case, index 1, which would be S, okay, it's not going to work. We can try that in our Replit. So let me just open up Replit. So it shouldn't work. Yeah, okay. But I mean, I think that seems fairly obvious given that this is not a list, it's a string, it's one word. So it doesn't recognize indexes, okay, within a string. While indexing a given character is fine, like by using the print A1 command, the A1 equals 3 command will generate an error because it attempts to modify an immutable object. There are lots of operations we can perform on strings. We will often use the plus operation, which can be used to join two strings together. When applied to strings, the plus sign does not mean add. It should be interpreted as either a join or append operation. So if we print A plus C, it's going to print good morning, okay, A plus B, sorry. It won't have a space, so just keep that in mind. That's why learning to format strings is very important. So if we just run this code, you see it prints good morning, but it's one word. We can put in an empty string and then just say plus B, and that should work to fix the problem. I personally don't think that this looks very nice though in terms of writing clean code. So I would use formatting. Notice how it also prints the length of the characters. So before it was 11 characters. The moment we added the space, it became 12 characters. As you learn more, you will be able to determine what an operation is based on in its context. In this case, when used with strings, you should see that the plus operation has joined the two strings together to form a new string. And remember, it's now contained within a variable called C. So let's now go a bit deeper into strings. A string is a sequence of characters. You can access the characters one at a time with the bracket operator. The second statement selects a character number from 1 from the fruit and assigns it to letter. The expression in brackets is called an index. The index indicates which character in the sequence you want, hence the name, but you might not get what you expect. So it's going to give us A, Remember, indexing starts at 0. Okay, so it's 0, 1. So you can, I was mistaken, you can use indexing on characters. It's just that you can't change a string or character in a string because it's immutable. So the reason is that you might not get what you expect is because for most people, the first letter of banana is B, not A. But for computer scientists, the index is an offset from the beginning of the string, and the offset of the first letter is 0. So to get B, you would have to use 0. So B is the 0th letter of banana, A is the 1st letter, and N is the 2nd letter. As an index, you can use an expression that contains variables and operators. But the value of the index has to be an integer, otherwise you get an error. Len is a built-in function that returns the number of characters in a string. To get the last letter of a string, you might be tempted to try something like this. So len, and then we've got fruit, last equals fruit length. The reason for the index error is that there is no letter in banana with the index 6. Since we start counting at 0, the 6 letters are numbered 0 to 5. To get the last character, you have to subtract 1 from the length. Okay. Or you can use negative indices, which count backward from the end of the string. So if you just say fruit -1, it will yield the last letter. Traversal with a for loop. A lot of computations involve processing a string one character at a time. Often they start at the beginning, select each character in turn, do something to it, and continue to the end. This pattern of processing is called a traversal. One way to write a traversal is with a while loop. So while index, and notice how we've initialized index to 0, is smaller than the length of the fruit, letter equals fruit index, print letter, index equals index plus 1. This loop traverses the string and displays each letter on a line by itself. That's why we have to keep adding 1 to index, okay, for each iteration to get to the next character. The loop condition is index smaller than len fruit. So when index is equal to the length of the string, the condition is false and the body of the loop doesn't run. The last character accessed is the one with the index, basically len fruit -1, which is the last character on the string. So don't be tempted to say smaller than equal, because remember that last index is not going to work. As an exercise, write a function that takes a string as an argument and displays the letters backward, 1 per line. It displays the letters backward. We can try that. Let's try that exercise. So we should create a fruit and let's call it banana. So I think our index should be length of fruit, okay? And then letter equals index minus 1, don't know, and then just say here, no. Fruit, banana, yeah. Fruit minus 1. Let's try that. No, that doesn't seem to work. So I've tried to initialize our index to the length of the index. When I say minus 1, it doesn't seem to like that. Maybe we can put it as plus, because remember, plus and a minus will give us a minus a banana. No, that didn't work. This loop traverses the string and displays each letter on a line by itself. So it did actually print A, so we got that right. Yeah, we actually got that right. We started with A. Now, how do we keep it going? Displays the letters backward, one per line. Well, we got A. Should I try with minus again? See what happens. Good. And banana. We did it. Not sure why I did it twice. But we initialized it to basically this character here, and then we just kept working backwards. Yeah, and then it did it twice. Another way to write a traversal is with a for loop. So for letter in fruit, print letter. Each time through the loop, the next character in the string is assigned to the variable letter. The loop continues until no characters are left. The following example shows how to use concatenation, string addition, and a for loop to generate an Abecedarian series that is in alphabetical order. In Robert McCloskey's book, Make Way for Ducklings, the names of the ducklings are Jack, Cack, Lack, Mack, Knack, Quack, Pack, and Quack. This loops put these names in order. So prefixes equals JKL, MNOPQ, suffix equals X. Okay, that makes sense. 4-letter in prefixes, print letter plus suffix. So J plus suffix, and so on. It will keep doing that over each character. Of course, that's not quite right because crack and is misspelled. As an exercise, modify the program to fix this error. I think I know how we could do that. We could use an if statement, and then we can just say if letter is equal to basically, and remember we need to use Q or use uppercase, okay? Because it's case sensitive. Q or O, it was those two, Q or O, yeah. Then we will print letter plus, then we need to add a U plus suffix, okay? Else, so only if it's Q or O, it will do that. Otherwise, it will use instead of. Let's just see if it works. Jack, 4-letter in prefixes. If letter prints. So it's the our if statement hasn't worked. Try wow. No, that won't work. 4-letter. Sorry, it is an if statement. Use instead of or true. I don't understand why it doesn't work. But clearly our if statement's not working. I'm trying to figure out why. That's because I'm used to iterating over lists, and now it's not really a list. true, stable. Let's look at our examples. So we had while letter equals. Is it equal? Am I getting muddled? Maybe that unexpected. No, it won't work. If Q or if Q in letter or O in letter. I think that's going to work. It worked! See the importance of not giving up. So we had to use in. Okay, so I think that was more of a syntax problem than anything else, but it worked. Each time through the loop, the next character in the string is assigned to the variable letter. Okay, we did that. Okay, we've done that. String slices. A segment of a string is called a slice. Selecting a slice is similar to selecting a character. So if we take S and then 0 to 5, remember we start counting at 0 and it's inclusive, and it will actually go up to index 4. Okay, so 0, 1, 2, 3, 4. So that's why it prints Monty. The operator NM returns the part of the string from the nth character to the nth character, including the first but excluding the last. This behavior is counterintuitive, but it might help to imagine the indices pointing between the characters. If you omit the first index, the slice starts at the beginning of the string. If you omit the second index, the slice goes to the end of the string. So we're seeing a lot of patterns here as to how slicing works. So this should help us in remembering basically these characteristics of Python. If the first index is greater than or equal to the second, the result is an empty string. Good to know. An empty string contains no characters and has length 0, but other than that, it is the same as any other string. Continuing this example, what do you think fruit means? Try it and see. I think it would be the whole character. So we can test that. So if we just leave it empty and we just say print fruit, I think it will print the whole word, which is banana. And that is correct. Strings are immutable. It is tempting to use the square brackets operator on the left side of an assignment with the intention of changing a character in a string. For example, we cannot change the H to J. All right. The object in this case is the string, and the item is the character you try to assign. For now, an object is the same thing as a value, but we will redefine that later in Unit 10. So that's fine. So just remember, strings are immutable. We can do that on lists, but not on a string. The reason for the error is that strings are immutable, which means you can't change an existing string. the best you can do is create a new string that is a variation on the original. Okay, so new greeting equals J plus greeting. And you see how we've actually used slicing to give us the rest of the statement. Okay. This example concatenates a new first letter onto a slice of greeting. It has no effect on the original string. What does the following function do? So we have a function called find. We've got two arguments, word and letter. We've got an index that we've initialized 0. And we are saying that while index is smaller than the length of word, if word, which is our argument here, and whatever the index is, equals letter, okay, return index. Index equals index plus 1, return -1. In a sense, find is the inverse of the square brackets operator. Instead of taking an index and extracting the corresponding character, it takes a character and finds the index where that character appears. If the character is not found, the function returns -1. So while index, that's basically to loop through a word. And then we can put in whatever letter we want. Remember, it's a function, so you want to be able to reuse it as many times as possible without having to rewrite the entire function each time. So let's say you want to find A in the word apple, and it will basically, the letter A, it will see, or it will search the word for that letter A, and it will return, for example, A, or the index. And it's a loop, so it will keep running through. This is the first example we have seen of a return statement inside a loop. This function breaks out of the loop and returns immediately. If the character doesn't appear in the string, the program exits the loop normally and returns -1. Pay attention here to our indexing. Okay. So it's right underneath the while statement. This pattern of computation, traversing a sequence and returning when we find what we are looking for, is called a search. As an exercise, modify find so that it has a third parameter, the index in word where it should start looking. We can try that. I don't know. We want a third start, maybe, because we want an index, the index in the word where it should start looking. Index equals start. I think that works. So let's test it out. So let's say print find. Okay. Now our word can be apple. We are looking for the letter A, but to see if our third, whatever you want to call it, our third parameter works, we're going to start at index 1. So it should return -1. Okay, so it works. If we say 0, then you will get A. It returns 0. Return index. So it's not quite working. So it's returning index. We made our index equal to start. Return not too sure. Say I don't know if that will work. Hmm. Right. Sorry. Um, can think of is changing it here. But then we don't have a third parameter, so that doesn't make sense. We need to add a third parameter. Um, Maybe if we change this into a for statement, right? Because we want to be specific. So for index smaller than word and index maybe greater than equal to start. Maybe now it will work. But there does seem to be a problem here. So I'm going to get an error. Cannot assign to expression. Take our initialization for index. No, we have to keep in initialization. The problem is because we have to initialize it at 0, right? What if we said index plus start? Let's change it back to while. So if we make it 1 as our start, it gives us -1, but if we make it 0, we should get A. No, we still get 0. Return index. Is it returning? I think it is working. Am I overreacting? It's returning the index. So let's try with L. Let's say L. But now or let's try P. Let's try P. And just to see if it's going to work, we're going to tell it to start counting from 0, 1, 2. Okay. It should give us 1P. Yes. So it is working. It is working. It's not returning the letter. It's just telling us where it repeats, which is at number 2. It's I think it's working. If we try 1, it'll give us 1. I don't know. It's a little bit of an odd one. The following program counts the number of times the letter A appears in the string. So we initialize count to 0 for letter in word if letter equals A, count equals count plus 1. So the logic is a little bit weird here, but every time A appears, it's going to take our count, which remember is going to be, it's going to keep occurring for as long as A is there. So like, for example, in banana, it's a for loop, so it's going to run over each character. It's going to get to the first A, and count's going to become 1. Then it's going to go again. And the moment it gets to second A, it's going to say 1 plus 1, so 2. So that's kind of the logic that we need to get used to. This program demonstrates another pattern of computation called a counter. The variable count is initialized to 0 and then incremented each time an A is found. When the loop exits, count contains the result, which is the total number of A's. As an exercise, encapsulate this code in a function named count and generalize it so that it accepts the string and the letter as arguments. Then rewrite the function so that instead of traversing the string, it uses the 3-parameter version of find from the previous section. Oh goodness, so we have to use our previous exercise. Well, I think the function part is not too tricky. I won't then delete that. So we're going to create a function called count, and yeah, it's going to contain 2 parameters. It accepts the string and the letter. So the string would be the word and the letter, and then we basically just copy this for letter in word. If letter equals, this gets tricky. We have to use, I think, some logic in here. I think we need to include our index equals 0. And then we need to say while index if equals letter, then we count equals count plus 1, and we're going to print counts. So I'm going to delete that. Count is possibly unbound. So I'm going to just cut that out, but I'm not going to delete it. So let's run our function. So we're going to print count, and we are going to use banana, and we want to check for the word A. Sorry, the letter A. So it should work. 3. Okay, so our function does work. 1, 2, 3. Okay. String methods. String methods that perform a variety of strings provide methods that perform a variety of useful operations. A method is similar to a function. It takes arguments and returns a value, but the syntax is different. For example, the method upper takes a string and returns a new string with all uppercase letters. Instead of the function syntax, upper and then in brackets your word, it uses the method syntax. So function syntax uses brackets. Okay, method syntax uses the dot. Okay, so that's actually something I've just realized now because it gets a bit confusing. Like when are we using a method or function? Notice how we can assign a new variable to it. This form of dot notation specifies the name of the method, so in this case upper, and the name of the string to apply the method to, word. The empty parentheses indicate that this method takes no arguments. Okay. A method call is called an invocation. In this case, we would say that we are invoking upper on word. As it turns out, there is a string method named find that is remarkably similar to the function we wrote. So we have dot find a. That's cool. In this example, we invoke find on word and pass the letter we are looking for as a parameter. Actually, the find method is more general than our function. It can find substrings, not just characters. So we can look for NA. By default, find starts at the beginning of the string, but it can take a second argument, the index where it should start. Aha. So word dot find. This would have been useful for the exercise we just did, where we got a little bit stuck. This will be the index to start finding, the second parameter. This is an example of an optional argument. Find can also take a third argument, the index where it should stop. So B, and we have 1. So it's saying start at 1, but stop at 2. So a third parameter equals where to stop. This search fails because B does not appear in an index range from 1 to 2, not including 2. Searching up to but not including the second index makes find consistent with the slice operator. Agreed. The in operator. So that's actually what we used on our little exercise for letter N word. The word in is a Boolean operator that takes two strings and returns true if the first appears as a substring in the second. So A in banana, true. Seed in banana, false. For example, the following function prints all the letters from word 1 that also appear in word 2. So for letter in word 1, if the letter is in word 2, we will print the letter. With well-chosen variable names, Python sometimes reads like English. You could read this loop. For each letter in the first word, if the letter appears in the second word, print the letter. Here's what you get if you compare apples and oranges. So we have both A, we have E, and we have S. The relational operator, sorry. The relational operators work on strings. To see if two strings are equal, we would use if. So if word equals banana, print all right, bananas. Other relational operators are useful for putting words in alphabetical order. So if word is smaller than banana, print your word plus comes before banana. Otherwise, it comes after, else, all right, bananas. Let's try that out. So that's quite useful for our little dictionary problem that we had. And there I was making it complicated. So let's create a function. So the function is named dictionary, and our argument will be our word. Now we just got to fix our syntax over here. If print banana. Okay, that looks a little weird. Else print. So now if let's check print dictionary apple should work. Sorry, we must put it as a string. So it should say comes before banana. Comes before banana. I think this is because of our indentation. So that's actually really great. Knowing that, we could actually, I think, solve our dictionary problem. So I think we'll actually go back to it. Our little dictionary exercise. So the greater than, less than operator will actually effectively put words in alphabetical order. And I'm going to make a note that this is on Strings Revisited, in case we need to come back to that. And this is exercise or chapter 10, part 10. Python does not handle uppercase and lowercase letters the same way people do. All the uppercase letters come before all the lowercase letters. So your word pineapple comes before banana. Important to take note, alright? A common way to address this problem is to convert strings to a standard format, such as all lowercase before performing the operation. Keep that in mind in case you have to defend yourself against a man armed with a pineapple. Funny. Debugging. When you use indices to traverse the values in a sequence, it is tricky to get the beginning and end of the traversal right. Here is a function that is supposed to compare two words and return true if one of the words is the reverse of the other, but it contains two errors. So word I, word 1, word 2, J. Oh, goodness me. The first if statement checks whether the words are the same length. If not, we can return false immediately. I remember doing this exercise. Otherwise, for the rest of the function, we can assume that the words are the same length. So when you want to check if a word is the reverse of the other, it would make sense, right, to avoid any unnecessary work, to first check if they're the same length. I and J are indices. Okay, I, J. So I think the problem here is the length of word 2. I think that's where the error is. I traverses word 1 forward, while J traverses word 2 backward. Because we have I plus 1 and then J minus 1. Okay, I think that makes sense. And two letters that don't match, we can return false immediately. So if word 1 I not equal. Oh, I think I know why. I think we need a for statement within this if. Or maybe not. Let's see. If we get through the whole loop and all the letters match, we return true. Are we still connected? Okay. If we test this function with the word pots and stop, we expect the return value true, but we get an index error. String index out of range. For debugging this kind of error, my first move is to print the values of the indices immediately before the line where the error appears. Now, when I run the program again, I get more information. The first time through the loop, the value of J is 4, which is out of range for the string pots. I and J. That's what I thought. Actually, so it should be, I think, minus 1. The index of the last character is 3, so that, yeah, the initial value for J should be len word 2 minus 1. If I fix that error and run the program again, I get true. This time we get the right answer, but it looks like the loop only ran 3 times, which is suspicious. To get a better idea of what is happening, it is useful to draw a state diagram. During the first iteration, the frame for is reverse as shown in figure 8.2. I took some license by arranging the variables in the frame and adding dotted lines to show that the values of I and J indicate the characters in word 1 and 2. Yeah, 0, 1, 2, 3. Find and fix the error in this function. Guys, I actually need to pause very briefly. Just give me a second. Sorry about that. We can see if we can figure out what the problem is, I guess. So now remember that we would need to just, first of all, fix up the first error here, or the first problem, which is -1. Now we can, let's try print is reverse, and then, yeah, let's try pots and stop. So it tells us true. I can't remember if we got this exercise right. So 0, 3, so 0, 1, 2, 3. Then it goes, then it compares, so it's comparing 0 and 3, 0 and 3, 0 and 3. Then it's going to compare 1 and 2. And then it's actually doing a duplication, 2 and 1. Hang on. 0, 0, 1, 2, 3. Then it's going to do 1, 0, 1, 0, 1, 2. Then it's going to do 2, so 0, 1, 2, and it's going to compare it with 0, 1. So the problem is we are missing 3 and 0. That's the problem. Basically this over here, but in reverse. I don't see that as an error though, because 0, which is in this case 3, right? Because we get up to 3 indexes, 1, 2, 0, 1, 2, 3, which is S. We're going to compare it with 0. Well, if 0 is 3, then surely 3 is 0 is going to be the same. find and fix the second error. I think the way I solved this problem was I sorted them in alphabetical order. And to me, that made sense then. It just took one of the words and sorted it, and if they were equal, problem solved. So as to how we would fix that problem, I don't know. But I understand what they're trying to say. I think my method, which was sorting it in alphabetical order, prevented those type of issues. Anyway, let's take a quick look at our glossary. So an object is something a variable can refer to. Now you can use object and value interchangeably. Sequence. An ordered collection of values where each value is identified by an integer index. Item. One of the values in a sequence. Index. An integer value used to select an item in a sequence, such as a character in a string. In Python, indices start from 0. Slice. A part of a string specified by a range of indices. An empty string is a string with no characters and length 0, represented by 2 quotation marks. Immutable. The property of a sequence whose items cannot be changed. Traverse. To iterate through the items in a sequence, performing a similar operation on each. So that's where we use our loops. Search. A pattern of traversal that stops when it finds what it is looking for. Counter. A variable used to count something, usually initialized to 0 and then incremented. Invocation. A statement that calls a method. Remember, when we call methods, we use dot. Optional argument. A function or method argument that is not required. So that's when we have like our brackets empty, or even our slicing. Okay. I see we have more exercises. So I am going to actually end the video at this point. The exercises are not necessarily something that can be done quickly, and probably I will just then dedicate a video to this. Of course, that by no means stops you from trying it on your own. And then we are, I think, nearing the end of Unit 4, because once we've done, actually possibly not, looks like as we've done going deeper with strings, then we've got string methods. So that doesn't look like it'll take too long, actually. It's just this one page. And then we still got 4.3. So, excuse me. also looks like it is one page. So in that case, we are nearly done. And I think depending on how the exercises go, we should finish this unit in a video's time. In which case, I look forward and I hope to seeing you in the next video. And of course, well done for making it this far. We are actually nearly halfway, and we are making extremely good progress in terms of our understanding, but also applying what we're learning so that we can get our certification in the basics of Python. Until I see you, God bless, and see you in the next video.